Hi everyone, in this video I will be doing some problems on analog circuits. The topic is diode circuits. I will be sharing the formula notes as well as the short notes that are required for doing these problems in the Telegram group. The link will be available in the description box as well as the PDF of this problems that are solved here, and also some more problems will be available in the Telegram group as well. And I have also given the link to my social media accounts where I share notes, updates, and everything like that. So if you want, you can follow that too. So we'll start with the first question. The output voltage V0 for the circuit is, we have to find out the output voltage V0 for the circuit when Vi is equal to 10 volt and Vi2 is equal to 5 volt. Okay. So we'll draw first for Vi1. Okay. So this is case 1. That was equal to 10 volt, right? Okay, and we are taking the output from this side. Okay, and now we'll see if the diode is forward biased or reverse biased. Positive terminal is connected to P side and negative terminal is connected. The thing here is that positive terminal is connected to this side is more positive compared to this side, right? So that means it is forward bias. It is not necessary that, please keep this in mind, it is not necessary that when having a PN junction diode, it is only forward biased when the positive terminal is connected to our P side is connected to positive terminal, N side is connected to negative terminal. So it is not necessary. It only means that P side should be more positive compared to the potential that is connected to the P side should be more compared to the potential that is connected across the N side. So by inspection, by looking at this, there will be voltage drop across this 2K. Okay, so it will be less than 10 volt only. So this one is 10 volt that is connected to P side. So from here we can conclude that this PN junction is forward biased. So D is forward biased. So what happens if it is forward biased? We are going to replace the diode with a short circuit. Okay, so that will be okay. So the voltage drop, these two are parallel, right? So the voltage drop across this will be 10 volt itself. These two are parallel, 10 volt, 10 volt. So this will be 10 volt, and 10 volt is being divided between 2K and 2K. So V0, applying voltage division principle, we get 10 into 2K divided by 2K plus 2K, which is equal to 5 volt. Okay, so the first question's answer is 5 volt, and now V0 equal to 5 volt, and now we'll see what happens when Vi is equal to 5 volt. Okay, so we are going to replace that with 5 volt. Whenever these kind of questions come, please see if the diode is forward biased or reverse biased first, and then proceed to do the questions. Okay. And now we can see this is 10 volt. From here we can see this terminal, this negative terminal is more positive compared to the positive terminal. That is our P side. N side is more positive compared to P side. That means this diode is reverse biased. So it will be open circuited, and the rest of the circuit will look like this. This 10 volt is being divided between 2K, 2K and 2K. And across this 2K only we are getting our V0. And now we are applying voltage division principle. We get 10 into 2K divided by total resistance is 2K plus 2k plus 2k, which is equal to 10 into 2k divided by 6k, that is equal to 10 divided by 3 or 3.3 volt. Okay, so here the answer is 3.3 volt. Okay, so that is the answer. Now let's move on to the next question. Okay, so Vi, this is a circuit given, and let V breakdown volt, the battery potential is equal to 0.7, and assume the input varies over the range minus 10 to plus 10. Plot V0 versus Vi. Okay, so the transfer function is asked here. So we should find out what is V0 versus Vi. So first of all, it is ranging from, our Vi is ranging from minus 10 to plus 10, right? So it will be, I'll take for minus 10. What happens to the circuit? And we'll see what happens to the circuit when Vi equal to minus 10. Okay, what happens to the circuit? Minus 10 10k 20k plus 10 volt minus 10 volt. Okay, so when it is connected to minus 10 volt, this diode is reverse biased. Okay, so I am going to replace that by open circuiting it, and what we will be left with is something like this: 10 volt, 20k minus 10 volt. Okay, no current will be flowing from here. So what will be the value of a V0 now? V0 equal to, we'll have to find it out by applying KCL. Applying KCL at node A. Say node A. Okay, let current be flowing away from the junction. We will get V0 plus 10 divided by 20k plus V0 minus 10 divided by 10k equal to 0. Okay, and from here we get V0 plus 10 plus 2V0 minus 20 equal to 0, and 3V0 minus 10 equal to 0, and V0 equal to 10 divided by 3, which is equal to 3.33 volt. So when it was minus 10, it will be 3.33 volt. And from here we can conclude that before Vi less than 0, that is when Vi is less than 0, diode is reverse biased. Okay, that is sure. And all these times our V0 is 3.33. Okay, and in this also it is given that it has a battery potential of 0.7. Now this V0 is having a potential of 3.33, and even if Vi becomes greater than 0, it will not be sufficient enough to forward bias the diode. Why? Because V0 now is 3.33 and battery potential is 0.7. So this input potential, input Vi should be greater than 3.33 plus 0.7 for forward biasing the diode. Okay, please keep this in mind, which is equal to 4.03. Okay, Vi should be greater than 4.003. Diode becomes on. Okay, and at last, at Vi is equal to 10 volt, what happens? Diode is on, and what will be V0? V0 will be equal to plus 10 volt. Diode can be replaced by this Barry potential, and this is plus 10, 10k, V0, 20k minus 10 volt. So what is equal to V0? V0 is equal to 10 minus 0.7, okay, which is equal to 9.3 volt. And now we'll draw the transfer function. So if I am drawing the transfer function is a plot of Vi versus V0, right? So before less than 0, less than 4.03, exactly 4.03, V0 was equal to 3.33. Oh, so I will be drawing like this, 3.33 until Vi is equal to 4.03. And when it is equal to 10 volt, what happens? Output was equal to 9.3 volt. So this is the transfer function of the required transfer function, okay? And now we'll see the next question. Now in this question, what is the circuit diagram of the clipper circuit for the transfer function shown in the figure? As you can see, this one is constant after 8 and this one is constant after minus 4. So this represents positive clipper, because positive half cycle, positive half of the Vi is clipped up, okay, and this one is negative clipper. And what in the case of positive clipper, diode will be facing like this, positive clipper, and in case of negative clipper, diode will be facing like this. These are shortcuts, and I am going to draw that for these two instances only, okay. So for clipping of 8 volt, diode should be connected to positive 8 volt, and for clipping of the negative side, diode should be, and also minus 4, like diode should be connected to minus 4, okay. Now come here, we can see that when it was 16 volt, the output was only 8 volt. To reach 8 volt, the input has to be 16 volt. That means there was a voltage division happened here, okay. So that means 16 volt was divided into equal parts, two equal parts. And here also we can see when it was minus 8 volt, it was output was only minus 4. So there are two resistances, let's say R, which are equal, and this is the input, okay. So this is the circuit for the above transfer function. This will look like this only, okay. Now let's do the next question. Okay, for the clipper circuit shown in the figure, the transfer function is, we have to find out the transfer function. Okay, from here I told you that when diode is facing downward, it is a forward, positive clipper, that is above portion, that is the portion above 12 volt will be clipped off. Yeah, I will just draw this. This will be like this. 12 volt will be clipped off. and the diode is facing like this in the opposite direction, that it means it is a negative clipper. So below -9 will be clipped off. Okay, and we have to see at what VI input voltage does this happen. Okay, you have to find out these 2 points. So when VI is equal to, let this be Vx for example. So Vx equal to, how much we have to find out, what was the VI at that point. Okay, that is VI when V0 equal to 12 volt. So VI is being divided between this resistance and this resistance, right? So applying voltage division principle, we have to find give the output like 12 volt. That is Vx is being divided between Vx into 3R divided by V0 was this one, right? 3R divided by 3R plus R. So Vx equal to 12 into 4 divided by 3, which is equal to 16. So I can write here it is 16. So it goes here. And now this point now V0 equal to -9 volt. What is VI? Okay, so that is equal to -9 equal to VI into again 3R divided by 3R plus R, and VI is equal to -9 into 4 divided by 3, which is equal to -12 volt. So the answer is -12 volt. So this is how it looks, -12. Okay, so this is a transfer function. I will redraw it over here. Sorry. -9 volt, -12 volt, 16 volt, 12 volt. Okay, VI, V0. Now let's do the next question. The clipping circuit is shown in the figure. The input varies from 0 to 50 volt. The slope of the transfer function plot between VI and V0 if the input varies between 3 volt and 9 volt. Okay, so that is a question being asked here. Now we'll see when VI is equal to 0. When VI is equal to 0, D3 was obviously off because it will be reverse biased. And at that time, what is V0? And what happens to D1? D1 is forward bias due to 6 volt. D1 is on and D2 is reverse bias due to 20 volt because the negative terminal is connected to positive terminal. So D2 is off. Okay, at that time I will redraw the circuit and it will look like this. K, 5K and 6 volt. So this was our V0. So V0 equal to 6 into 5 divided by 10, which is equal to 3 volt. Okay, and now so D3 is off until VI is greater than 3 volt, because at this point V0 is 3 volt here, V0 is 3 volt here. This is reverse biasing our D3. So to overcome that, to make it forward bias, our VI should be greater than 3 volt. So D3 will be remaining off until 3 volt. Okay, and now I'll write the, when it is equal to 9 volt, what happens? When VI is equal to 9 volt, D3 is on, D1 is, it is equal to 9 volt. Okay, so this terminal is more positive compared to this terminal. Okay, then our D1 will be off and D2 is off. Okay, to make D2 on, it should be greater than 20 volt, but here only we are giving 9 volt only, so D2 will not be on. So what happens to our V3? What happens to our V0? Okay, 5k, 2.5k, it's 9 volt. So V0 equal to apply voltage division principle, 9 into 5 divided by 7.5, which is equal to 6 volt. And now I will draw the transfer function. So Vi is equal to 0 volt, or if Vi less than 0 volt, what at the output was V0 equal to 3 volt. And when Vi greater than 3 volt, it started conducting. And when Vi is equal to 9 volt, what happened? V0 equal to 6 volt. So it will look like this. Up to 3 volt it was like this. When it reached 9 volt, it was 6. Okay, and now slope is equal to 6 minus 3 divided by 9 minus 3, which is equal to 3 divided by 6.5. So this is the answer.